In this video, we'll discuss a few more examples about indefinite integral. So given a function f of x, the indefinite integral is basically the most general antiderivative of this function. So this is basically another notation for the antiderivative, right? This is the most general antiderivative of f, right? I dot e, if you have f prime of x equal to f of x, right? If you have a particular antiderivative, then the indefinite integral, the most general antiderivative, is basically equal to f of x plus a constant, right? So that's basically what is about the indefinite integral. So we have a shortcut notation for the antiderivatives. So let's see some examples using the list of elementary function antiderivative, right? Let's see the first one. Let's see what's the integration of tangent square of x dx. So this is a indefinite integral, right? How do we get that, right? If you recall the memory, recall the list of the antiderivatives. We don't know whose derivative equal to tangent square, right? And but we do know that tangent of x prime is secant square. So which means the antiderivative of secant square is tangent. And also by the trigonometric trig function identity, uh, tangent square of x plus 1 equal to secant square of x, right? Which means tangent square of x equal to secant square of x minus 1, right? So now we are ready to figure out the indefinite integral of tangent square because we do know whose derivative is secant square and whose derivative is 1, right? So our function is basically equal to integration secant square of x minus 1 dx, right? Whose derivative, this is the same as by the uh, derivative laws. This is same as secant square of x dx minus integration 1 dx. These are both elementary functions. We know their antiderivative. So this is tangent of x then minus x. So this is a particular antiderivative. To make it the most general one, you plus a constant in the end, right? This is basically how do we figure out the most general antiderivative of a given function. Okay, now let's see another example, right? More examples. Example 2 here, let's try to figure out what's the antiderivative of this function. Integration 1 plus root x plus x over x dx. So we are looking for whose derivative equal to this fraction, right? Now, how do we do that? And this antiderivative is linear. What's the meaning of that? You can split big term into a sum or difference, right? So look at this function. Let's refresh you, recall two things, right? One is the power function. So if you have n here is different from -1, integration of x to n dx is always 1 over n plus 1 x to n plus 1 plus constant, right? And the other one is if you have n equal to -1, which means x to n is 1x dx. So this is the natural log of absolute value of x, then plus a constant, right? So that's two uh, functions. We know their antiderivative, right? So let's try to split our function into three terms. We can make it a smaller function. We know how to integrate. So this is equal to integration 1 over x plus root x over x plus x over x dx, split it. So this is the first term is good, integration 1 x dx plus integration. The second term is x to 1 half over x, right? So which means this is uh, x to 1 half minus 1. So x to -1 half dx. And the last term is integration 1 dx. The first term gave you natural log of absolute value of x dx. And no dx anymore, right? Then plus that second one is a power function whose exponent is not -1. So this is x to -1 half plus 1 over -1 half plus 1. Then plus, this is x, and plus a constant, right? If you want to simplify this, so this is natural log, the absolute value of x, plus -1 half plus 1 is 1 half. You get 2 times root x plus x plus constant. So that's the antiderivative of this function here, right? We can apply rules to evaluate the antiderivatives. Now let's see a third example. Let's see this one, right? The third example. Um, okay. Um, Integration u plus 2 uh, 2u plus 1 du, right, as a product of two linear functions. Again, here we don't have any formula for such kind of product. We don't have product rule in the integration. So we just need to change it to a sum or difference of elementary functions, right? You can factor out, and then use a integration of power function integration u to n. So n here is different from -1. du is u to n plus 1 over n plus 1 plus a constant. So u here can be x, can be any other letter you want, right? So this is basically the integration of 2u squared plus 5u plus 2 du, right? And this is 2 times u cubed over 3 plus 5 times u squared over 2 plus 2u plus a constant c. So that is the antiderivative of this big product. we have to factor out into smaller terms, and that's a sum or difference. We can split it into smaller integrals, then figure out one by one, and then add it up or subtract it. We get the most general antiderivative, right? So let's see. Because if you know the antiderivative, you know how to calculate a definite integrals, right? So let's see an example uh, of definite integrals, right? And so let's see examples here. Let's see integration from 1 to 4 and square root y minus y over y squared dy, right? Any letter, the letter name doesn't matter. This is same as replacing all the y to x or t or anything you want. So this is a definite integral. So all you need to do is figure out the antiderivative, which means an indefinite integral of such a function, and then you plug in 4 and 1, do a subtraction, right? So same trick. This clearly corresponding to some power function, right? So to power function, we have two cases, x to n is non-negative or 1x. So let's see what we have. This is integration from 1 to 4, root for y over y minus y over y squared dy, right? Root y over y squared. And so this is integration from 1 to 4 y to the power of 1/2 minus 2, which is negative 3 over 2. Then minus 1 over y dy, right? And so this is y to negative 1/2 over negative 1/2. That's the antiderivative of the first term. Then minus natural log of the absolute value of y. Then plug in 4, plug in 1, do a subtraction, right? If you plug in 4, so the first term is negative 2, switch negative 1/2 to the numerator, you get negative 2. Then times 4 to the power negative 1/2 is 1 over 4 to 1/2. 4 to 1/2 is 2, so this is 1 over 2 minus natural log of 4, then minus negative 2 times 1. 1 to negative 1/2 is 1, right? Minus natural log of 1. Natural log of 1 is 0. So the answer is negative 1 minus natural log of 4, then plus 2. So this is 1 minus natural log of 4, right? So we can use the indefinite integral to evaluate definite integrals. So that's the examples we want to discuss for the indefinite integral in this video. So yeah.